NASA has confirmed 2023 as the warmest year on record. Heat-related risks have seen an increase. I will give you an example of their consequences. This is the beautiful Xiangshuitang Reservoir, known as the Mirror of the Sky. However, after the heat wave in 2018, it was also a dry pond. This has also caused a water shortage crisis in nearby villages for 10 days. So the government must provide temporary water tanks to supply drinking water to the villagers. In the same autumn, the government constructed a tide water supply system for this area to resolve the issue. Therefore, we didn't observe similar reports during the 2022 heatwave. We obtained these insights using Havior. See details in paper case. So, what is Havior? We proposed an LLM-empowered visual analytics system to help experts in the environmental domain research on heat risk management. The system can efficiently integrate heterogeneous understanding from the numeric domain models and textual news reports. In Havior, experts can set and load the meteorological data of their interest. In the gallery of cities, we design thermoglyph for each city. It can intuitively show the relationship between temperature and percentile and the current value for experts when selecting a city. For instance, the thermoglyph for Hong Kong exhibits a concentrated pattern on the left side, indicating that the temperature in Hong Kong is more concentrated for the most of the time. On the other hand, the thermoglyph for Beijing showcases parallel distribution, representing the broader temperature range and distinct seasonal characteristics observed in Beijing. Then they can analyze the temporal trend, temporal distribution, and spatial distribution in the temporal view and spatial view. They can change climate variables to analyze as well. Then, experts can use keywords to retrieve relevant news. After loading news, their statistical information is shown in the temporal view and spatial view, respectively. Here, we can see the consistency between heterogeneous numerical domain data and news results. It enhances the interpretability of the system for heat risk research. See details in paper case. The topic view displays the hierarchical topics of the retrieved news in hexbins. They cover many risk aspects for experts to explore. We use grayscale to encode the number of news on a specific topic. The layout of hexbins remains the relevant distance of the semantic meaning of topics. When mouse hovers over the hexbin, the bar will change color to indicate the proportion of news quantity. Each news glyph encodes information about death, injury, and impact, so that the important news will be in large glyphs. Experts can zoom in to select news. Now, when experts click on the largest news glyph, the corresponding news will automatically be centered in the spatial view and positioned at the top of the news list. For each piece of news, experts can click the button to show its structural information extracted by LLM. Similarly, experts can read the full text. In particular, we use visual cues to map the structural information with the corresponding sentences in the full text. This design can help experts read news easily and quickly. During the analysis process, experts can pin their findings to the summary panel for later review or as a reference for generating the final report. Experts can use the sentence or news to rank the news list and find more news that interests them. Experts are interested in the topic of the water crisis. He can click hexbins to switch topics. In this topic, there is only one news item with a new glyph. Experts directly click on it. It's about the water shortage in a village we talked about in the beginning. Experts can filter news by directly brushing the 3 bar charts on the top of the news list. Experts can pose their contextual questions with the help of RAG. LLM will generate accurate answers by referring to the news in the news list. In the end, the system can generate the report based on the results of the numeric domain model and the insights they obtained.